The time dilation paradox. This phenomenon occurs because time is not absolute but slows down for an object as it moves closer to the speed of light. From the perspective of a stationary observer, a clock on a fast-moving spaceship appears to tick more slowly than one on Earth. While it feels perfectly normal for the traveler, this fundamental shift in reality has been proven by placing atomic clocks on high-speed jets and comparing them to those left on the ground. The length contraction paradox. As an object accelerates toward extreme speeds, its length actually measures shorter in the direction of its motion from the viewpoint of someone standing still. A spacecraft that is 100 feet long at rest would appear to shrink significantly if it zipped past at 90% of light speed. This isn't just an optical illusion or a trick of light. The physical space occupied by the object literally compresses due to the way space and time are linked. The twin paradox. This famous thought experiment involves one twin traveling into deep space at relativistic speeds while the other stays home. Upon returning, the traveling twin is much younger than the sibling who remained on Earth. The confusion often arises because motion is relative, but the paradox is resolved by the fact that the traveling twin had to accelerate and change directions, breaking the symmetry between the two paths through the universe. The ladder paradox. Imagine a ladder that is slightly longer than a garage, moving so fast that length contraction makes it fit inside perfectly. For the person holding the ladder, however, it is the garage that has contracted and become even smaller, making it seemingly impossible to fit. The solution lies in the relativity of simultaneity, meaning that different observers cannot agree on whether the front and back doors of the garage closed at the exact same moment. The mass-energy paradox. As an object approaches the cosmic speed limit, it becomes increasingly difficult to accelerate it further. This happens because the energy used to push the object begins to manifest as an increase in its relativistic mass or momentum, rather than just more speed. This relationship leads to the realization that mass and energy are essentially two forms of the same thing, a concept that eventually redefined our understanding of nuclear physics and the stars. The velocity addition paradox. In our daily lives, if you throw a ball forward while standing on a moving train, its speed relative to the ground is simply the sum of the two velocities. In special relativity, this simple math fails because nothing can ever exceed the speed of light. Even if two high-speed particles are heading toward each other, their combined relative speed will always be calculated using a specific formula that keeps the result below that ultimate universal limit.